Problem solving using algebraic equations. There are 5 basic steps to solving problems using algebra. Identify the unknown quantity and allocate it a variable such as x. Translate the problem into an equation. Solve the equation by finding the value for the variable. Check that the solution satisfies the original problem. And finally, write the answer in sentence form, and this should describe how the solution relates to the original problem. For example, in this problem, we're told that 2 more than 3 times a number gives a result of 23, and we need to find the number. So we'll let the number be x. 2 more than means add 2. 3 times the number would be 3x, and gives a result of means equals, and the answer in this case should be 23. So the equation should be 3x plus 2 equals 23. And then we solve this using normal inverse operations. So if we take 2 from both sides, we end up with 3x equals 21, and then divide both sides by 3. And that leaves us with x equals 7. To check that 7 satisfies the original problem, 7 times 3 would equal 21. And if we then add 2 to this, we would get 23. The last part of the answer is to write a sentence which explains our solution. So the number is 7. In this problem, we're told if 8 is subtracted from 5 times a number, the result equals 7 added to 3 times that number. And again, we need to find the number. So we'll let the number be x. 5 times a number would be 5x. And if 8 is subtracted from this, the first part of our equation is 5x take 8. The result equals, so this is our answer, 7 added to 3 times that number. 3 times the number would be 3x, and we need to add 7 to that. So our equation equals 3x plus 7. We now solve this using normal inverse operations. Firstly, get the unknowns all to one side. So if we subtract 3x from both sides, we're left with 2x take 8 equals 7. Then add 8 to both sides, and we have 2x equals 15. Last, divide both sides by 2. We end up with x equals 15 on 2, or 7.5. So the number is 7.5. Algebra can also be used to solve problems involving measurement. In this case, we're told that the width of a rectangular block of land is 2/7 of its length. If the perimeter of the block is 252 meters, we need to find the length and width of the block. In the case of a question like this, it's always good to draw a diagram and label it with any information that the question gives. In this case, we're going to assign the length as L. The width, we are told, is 2/7 of the length, so we will call W 2/7 of L. We know that the perimeter is 252 meters, and we know that an equation for the perimeter is 2 times the length plus 2 times the width. We substitute our variables for length and width into this equation, which gives us 2L plus 2 times W, which is 2/7 of the length, equals 252. We now simplify the equation, so we have 2L plus 4L over 7 equals 252. To solve this equation, which involves a fraction, we need to create a common denominator. So we times 2L by 7 over 7 and 252 times 7 over 7. This gives us 14L over 7 plus 4L over 7 is 1764 over 7. Now that the denominators are all the same, we can equate numerators. 14L plus 4L is 1764. Simplifying the left-hand side gives us 18L is 1764. Divide both sides by 18 and we find the value of L is 98. To find the value for W, or the width, we substitute 98 into our equation. W is 2/7 of the length, or 2/7 times 98. We find that W is equal to 28. To check this, we would times 98 by 2, add 2 lots of 28, and this comes to 252, which is our perimeter. So the last step is to write a sentence answer explaining what L and W are. So the length of the block is 98 meters. And the width of the block is 28 meters. For some questions, it's helpful to set up a table to assist in constructing the equation. We're told that Ross is 20 years older than his niece Crystal. Crystal has worked out in 5 years' time her uncle will be twice as old as she will be, and we need to find Crystal's age. So we'll let Crystal's age be X years. If her uncle Ross is 20 years older than she is, then his current age is X plus 20 years. We draw up a table with Crystal and her uncle in the left-hand column. We know that their ages now are X and X plus 20. We can then use this to work out their age in 5 years' time. So in 5 years, Crystal will be X plus 5 years old, and her uncle will be X plus 20 plus 5, or X plus 25 years. The question says that in 5 years' time, her uncle will be twice as old as she will be. So in 5 years, her uncle will be twice as old as she is. This helps us to set up the equation we need to solve. So in 5 years, her uncle's age is X plus 25. But this should equal twice Crystal's age in 5 years. Now that we've constructed the equation, we need to solve it. Firstly, we expand the brackets on the right-hand side. Then we rearrange the equation so the variable is on the left by subtracting 2x from both sides. That leaves us with negative x plus 25 is equal to 10. We then take 25 from both sides. We find that negative x is equal to negative 15. This leaves us with x is equal to 15. We'd originally assigned x to be Crystal's age in years. To check this answer, if Crystal is 15, then in 5 years' time, Crystal would be 15 plus 5, which is 20 years, and Ross should be 15 plus 25, which is 40 years, which makes Ross twice as old as Crystal. The last part is to write a sentence answer explaining what x equals 15 means. In this case, it's Crystal's age. So Crystal is 15 years old. Constructing a table can also be very helpful for algebraic problems involving money. For example, in this case, I have 25 coins in my pocket, all of which are either 5-cent or 20-cent coins. Their total value is $2.90, and I need to find how many of each do I have. And I need to find how many of each of them I have. So we'll let the number of 5-cent coins be x, which means the number of 20-cent coins must be 25. That is the total number of coins I have minus the number of 5-cent pieces. We now draw up a table. We put the coin values in the left-hand side. In this case, we have 5-cent coins and 20-cent coins. We've assigned the number of 5-cent pieces we have as x, and the number of 20-cent pieces is 25 minus x, because we have a total number of coins of 25. The total value. To get the total value of 5-cent pieces, we times 5 by x. And to get the total value of our 20-cent pieces, we times the 20 cents by 25 minus x. We know that their total value is $2.90, but we convert this to cents. So a total value of 5 and 20-cent pieces should add up to 290 cents. This now helps us construct the equation. Using this last column, we know that 5x plus 20 lots of 25 minus x should equal 290. Should equal 290. And now we solve the equation. Expanding on the left, we have 5x. Expanding on the left, we have 5x plus 500 minus 20x equals 290. Simplifying gives us minus 15x plus 500 equals 290. Subtracting 500 from both sides. Subtracting 500 from both sides leaves us with minus 15x equals minus 210. Lastly, dividing both sides by minus 15 gives us x equals 14. We go back to our original problem and find that this indicates we have 14 5-cent pieces. To find the number of 20-cent pieces, we subtract 14 from 25. This means I have 14 5-cent pieces. To find the number of 20-cent pieces, I subtract 14 from 25. To find the number of 20-cent pieces, I subtract 14 from 25. Which equals 11.